Yeah, so this is going to be a more of a high level presentation, but I'm also going to go into details about some of the like tricks, like just like the tricky parts and how to come up, like put together these visualizations together and use the widgets and the widget updaters and all of that stuff. So it will go into the pub sub and also accessing data and all of that stuff. So you've all seen some of these interactive visualizations, how basically using an episode or so using some widgets, you're able to control other widgets. Some of these are interactive, some of them control others and and some of them also only depend on others and they don't control other widgets. So there's definitely some communication going on between these widgets. And in the past, I've when I started building these visualizations, I had all of those, especially the ones that depend on each other or send messages to each other. They needed to be in the same class, or at least they needed to have some reference to be able to uh, talk to each other. So, for example, this is a subset of like the kind of messages that need to be sent, or like the dependency graph. Basically, like the episode is going to control a lot of widgets. For example, the episode here controls this ground truth mesh visualizer. It controls this figure. It controls the info widget here and a lot of others. So what ends up happening is that you end up creating a huge class with a lot of these widgets very tightly coupled. And if you want to extract some of this functionality and move it to another plot, it becomes very difficult to do so. Um, so the idea here with introducing PubSub is that we can actually decouple all of those dependencies. So when the episode changes, we don't define what happens when the episode changes. Instead, we just say, okay, the episode is going to publish a message on the topic episode number. And then any other widget can subscribe to that topic and say, and see, for example, that the episode has changed and do stuff in their own class. So we can now decouple all of that communication. So again, here with direct communication, basically like an episode directly controls other widgets. If you have widget one, maybe as an episode slider, it directly controls some of these. So if you want to add a new widget that depends on widget one, you'd have to go into the callback function of when the episode changes in widget one and modify it so that it talks to widget five or something like that. And this just makes it very difficult to add or remove any new widget, but also to extract functionality and reuse it somewhere else. So that's what PubSub models give us. So basically, you can think of these as the topics in the middle here as kind of like a broker. It's so you basically the publisher, it only knows that its topic name is episode number, and it publishes it on the event bus or the broker basically. And if you have any subscribers to that topic, the message will get relayed to them. If you don't have, then the message will be lost basically. So that's the idea. So you can basically very easily add a new subscriber and say, okay, I want the subscriber to depend on topic two, or I want it to depend on topic one and two, and it just listens to those topics. And then you can take that subscriber, move it to another plot, and as long as someone is publishing those messages, then it should be able to work fine. And these are all split into different classes. So you can just copy that whole class, move it somewhere else, and it will work. I'll show an example of this at the end.
Yeah, and maybe you'll cover this in a bit, but in terms of like the one-to-many publisher to topic um, arrows, so is that like,
Um,
I guess how complex can a topic be? Because kind of naively, I would imagine a topic is just kind of like one variable, and it's
you,
just kind of passing it into this kind of, yeah, almost
yeah,
like a global namespace. But
you could publish multiple things if you want. So it's usually what I've used it for is just publishing one on one topic, just to say like basically the state of this widget is this. But you could you could publish multiple things on different topics. It depends on how you want that resolution or the like this. So, for example, you could publish uh, like a hypothesis on one topic and just say this is the hypothesis, or you could publish it on multiple topics and say this is the hypothesis location and this is the rotation. So that if you have this granularity, then you can have multiple widgets only using this part, like only listening to one topic and not the other.
Yeah.
So it depends really on the granularity that you want to have.
And I guess you could also have like two publisher widgets that affect a particular topic in different ways. So like I guess if the topic is like step number, then changing the step slider changes that. But also if you change the episode, presumably that tends to change the step to 0 or something like that.
Yeah.
Um,
So the way I do it is that I make the episode change the step, and then the step publishes a step number again. So it goes into this loop. But I've
oh,
been
okay.
in,
So okay, because that does seem maybe a bit cleaner. So then it's kind of a published topic subscriber, and then it has its own published to change the step. So then
yeah,
it wouldn't really be two arrows like this. It would be like you say, like a loop.
yeah. The problem with that is that it can sometimes because it's a loop, so the um, yeah, it takes more time to get to the to equilibrium basically because the once you if the publisher sends to the step number and then the step number changes and publishes, that takes two steps. It's like message passing in graphs.
Yeah. Okay.
So
So yeah, okay, interesting. So is there
yeah.
almost like an upper bound on the number of message passes that are allowed before?
Well, I don't have that, but it's just sometimes you'll see a lot of things changing and they'll just reaches equilibrium. That's when I know that. But we can have debouncing to get rid of this as well. I've been thinking about it, but it's not really an issue so far.
Yeah, no, that's interesting.
But there are actually some, like I can have multiple publishers or multiple widgets publishing the same topic. Just like here, for example, in here, I have these, like the primary target and then these arrows. These are three different widgets, these are three different buttons, but they're really changing something, that topic called current object, which is like which hypothesis space are we looking at? Right? Because you could be at an episode uh, and a step, but you want to change which hypothesis space you're inspecting. It could be you want the mug or you could want something else. So the primary target always resets back to the primary target of this episode, and these can move right and left. So they cycle through the objects, the hypothesis spaces. So they all can publish to the same current object topic. So that is sometimes useful, right? Um, but anyway, so we have these. So we can look at this here as just a collection of widgets. And these widgets, like I said, they're independent. They only talk to each other only through the pub/sub topics. So you can move them, take them into a different plot and reuse the functionality. So let's go through some examples before we go into the actual code. So if we just look at the episode slider can, in this case, we only wanted to output an episode number, right? So the way that I've defined this in code is using something called a state to messages. The widget class is going to call these function names that I've defined. So this is the pattern that I'm using, but I'll go through that later. But the only thing that we need to know here is that this is kind of like a payload function. So that's where you define what topic is being published and what is the value of that message on that topic. So what message is being published and what the value is. And we'll get more into details about this later. But the episode only publishes the episode number. And that's what we see here. It can publish multiple things, but right now it just only publishes the episode number. If we go to the step, now the step receives the episode number and it publishes the step number. So publishing the step number is exactly the same way. I have the state to messages and I'm just telling it to publish step number. But receiving is a little bit more complicated because I wanted um, so I created these widget updaters, and you can have multiple updaters. You can have there are a lot of scenarios where the widget can change based on what it's listening to. And sometimes you'll have multiple updaters, or you'll have one updater. Sometimes you have one updater that listens to multiple messages or multiple topics. And when it has enough messages in all of them, it can update the step widget. Um, in this scenario, we have one updater. What it's doing is it's listening to episode number. And once it gets a message, or if the episode number changes, it will call this callback function, which is it's going to update the range basically. So because we have like episode 0 could have 50 steps, episode 1 could have 20 steps or whatever. So we need to modify the range of the step slider. So once the episode number changes, it calls this callback function. So that's a simple example here. Let's go to more complicated examples, like this correlation plot, for example, here. What's happening here is that this one is listening to 4 topics: episode number, step number, current object, which is basically which hypothesis space, and it's getting those from the buttons and the arrows that we had before. But also age threshold. So it's listening to those 4, and if any of those change, it will call the function update plot, which is going to modify this widget. This is why I call them widget updaters. The only way you can modify the widget that you're on is through widget updaters by listening to some topics or some messages.
And
So go
so,
ahead.
and just to clarify, so and each widget, would it always have one widget updater, or could it potentially have multiple?
It can have multiple. I have an example for that. But
Okay,
yes,
cool.
you can have multiple updaters, or you can have no updaters if for example, you're not listening to anything, but you're only publishing, just like the episode slider. It's not listening to anything, but it's only publishing which episode you're on.
Right. Okay. And then yeah, maybe again that'll be an example of this, but I'm just kind of curious now. So with the topics, so yeah, here is an example where if you change any one of these, it's listening, it will call the callback. But
Yes.
presumably there's also a notation for if all 4 of these must change in order
Yeah.
to
So
call the callback or
yeah.
something like that, or like multiple
So
things.
required here, basically. So if you list a topic, that means that if any of these topics change, you will call the callback.
Okay.
Required means that this topic is not really required for update plot to call it, right? Sorry, do you hear that noise?
Yeah.
No,
No.
sorry. Um, so basically, required is basically saying that I need to have this topic in in the list of messages that I send to update plot. So if you set it to required, then it's not going to call update plot until all of these messages are available. But if you but just by listing them here, if any one of those changes, that basically says call update plot. It's a tiny detail, and it's in most cases you only need required to be true. I had only needed it for one case, but yeah, I don't think it's worth time going through it, because always required is true is usually sufficient.
Is there a difference between the variable changing versus the variable being available? Like I assume only one of these will change at any one point in time, but you need all 4 of them to update. So like, does it check, oh, is this value in the middle circle right now available? And that's what the required looks like.
Yeah, so the widget updater is going to keep an inbox of all of these. So it basically stores these messages, and only when all the required messages are available, it will update the plot. Sometimes you don't have, sometimes episode number is not yet available in the inbox, but one of these change, and you still want to update the plot. So that's the difference. So sometimes you don't have episode number yet, and update plot doesn't really depend on it. So you'd still send the message if step number changes, for example.
But if all of them are available, but none of them have changed, do you
Then it
still
won't
update the
send.
plot?
No,
Okay.
only when it changes, because it's just going to be the same function being called again and again. It doesn't matter. It doesn't.
And then
Okay.
and then the logic for all of them being required, that's specified in the inbox.
Yeah.
If you wanted that to be the case.
So yeah, so that's the logic for this inbox stuff is in the class of the widget updaters, and um, you basically just set it required equals true, and it will not send a message without all these four, basically.
Oh, okay.
Did I
Okay.
answer your question? Okay.
Yeah.
Now, the output, which is going to use again the state to messages, and again, you can really just change. So you can customize this as much as you want. Um, so here I'm just sending out two messages. Sometimes if I don't have a selected hypothesis, I send a message. I send on a topic called clear selected hypothesis with a value of true. You can just say selected hypothesis with a value of none. It really depends on what you want to send. So this is like a payload function that can just take the state of the widget and can modify it or do anything to it and then just send it.
Is state to message supposed to be like a protocol? Like it must take in some state and it must return some iterable topic messages. Like it can't just
Um,
return like random things. Like
yeah, it has to
yeah.
return a list of topic messages,
Okay.
which is so because every one of these topic messages, it's going to iterate over them and it's going to publish it. That's in the widget class. It's doing that. Here, you're
Okay.
just defining the payload function, but when you return
Okay.
those, it's going to go over those. And then the state doesn't have to be. Uh, so I have this notion of a widget and a state, and the state of some of those. It makes sense for some of these widgets to have states. Like for
Right.
example, the slider, the state would be the value of that, or the button would be the value of that. Some of those widgets, they don't necessarily have a state. So it will, if it doesn't have a state, it will basically return sometimes none like this. And you just put whatever state you want in here when you're
Okay.
defining that.
Okay. But it is like a very minimal contract that must return some iterables of topic messages.
Yeah, because all these
Yeah.
messages are going to be published. So if you
Okay.
don't have any messages to send, just return an empty list.
Okay.
Or just don't have state to messages at all. Okay, here's another slightly different example. This one doesn't publish anything, so we don't have state to messages, but we have updaters. And this is one example where we actually need more than one updater. And the reason is we need one updater that's going to update the mesh, and this one only listens to episode number. Because this is the primary target mesh, so it only changes with the episode. So if the episode changes, the primary target changes, and we want to update the mesh to some other um, object. But then we also want to listen to episode number and step number. So if any of those change, we want to update the sensor on the object. So we want to move the sensor to a new location. And I do this because if the step number doesn't change, I don't really need to update the mesh. It doesn't make sense to do that. So I have split the update mesh and update sensors, and I'm just defining what topics they need to listen to.
Yeah, nice.
Okay, so that's basically a very high level view of these, and we can now go to we can discuss more on like low level details of these things. These are the topics I plan on discussing. the first thing is not really related to PubSub, but it's more related to tbp.plot or some helpers for accessing data, JSON data from the detailed run stats. And then I'm going to talk about adding a plot into the registry. How do you register that plot using the CLI interface, which is pretty cool. And then creating widgets with widget ops. This is more involved. And then there are some tricks that I'm going to discuss about debouncing and deduplicating events, because we don't really, sometimes it becomes very, yeah, so if you're changing the slider value, it can just keep sending on messages, because every movement is just changing the value. So we don't want that. We want to gate all of these outputs and only send messages when necessary. So this here is going to touch on that.
Do all of the, it always depends on JSON files being logged?
Yes, right now it does, but that's only part of it. So if you have another way of loading the data, it doesn't really need to depend on JSON. So you will see I'm using something called data locator and data parser to parse the JSON and locate data. But if you are doing this online, then you can just have a different type of data locator.
Okay, cool.
So I added a tutorial for accessing data. It's right here, which basically goes through this, the same stuff, but I'm going to go through it again. So basically we have a structure like this. This is a very simple structure. Usually our JSONs are much bigger, and they're like I don't know, 7, 8. The depth of the structure is usually a lot more. So this is why it's useful. But let's take this example here, a simple example. If we have this as a simple example, we have a dictionary. We have one level here. We have the episode numbers, and then for every episode, we have a list of dictionaries. So the second level is a list, and then the third level is another dictionary. So if we want to access some data here, so the way that I do it is I define a data locator, and in this data locator, I define all of the steps that I need to reach some data somewhere. So I say, so it's usually either a key or an index, a key for dictionary and an index for a list. So I say this data locator has a step that is a key, and I'm going to call it episode, and I'm going to give it a value of episode 2. And then the second path step is index, is going to be step and value of 3, and then key, I'm going to call it field, and I'm just going to get evidence. So if I run this with the parser and I just say extract, and I give it the data locator, it's going to return the value, basically 0.5, which is where we are. Now you can reuse that locator, but it's not really useful if you can't either quickly modify this data locator or define it in a way where you can, where you know that a lot of these are constants and you just want to define the missing values. So I rarely use a full locator path like this because every data, all the data that I'm extracting really depends on some slider value or some button or something I don't know what the episode is until I get the episode value from the slider. So what I ended up doing is you can define the same locator, but in a partial way. This is inspired by partial functions from Python. So basically, what you would do is you would not specify a value here for whatever step that you're missing. So here, I don't know what the step is, and I'm going to rely on the slider later on to get it. So I can just keep that missing, and I can call the same function parser.extract, and I give it the partial locator, and then now the step that I want. So you don't have to specify all of these steps again. So that would be the idea. And then it returns, give it step 0, 1, 2, 3, whatever. It will just return the right value. The other cool thing that you can do with this is that you can query the available options here. So instead of just having, instead of extracting data, you can query what available episodes are at this step. The way this works is that you would have missing values when you don't really know what the value here for episode is, and parser.query instead of parser.extract. This one will just go through these steps and it will stop at the first missing value and it will tell you these are all the available options for you. So you could use that to it's useful when you're deciding like what is the range of the slider, or if the slider range changes based on the step range changes based on the episode. You could use that to always query how many steps you have, or how many objects you have, what are the objects, stuff like that. But if you give it an episode number, it will basically go to the next missing step and it will return to you the available options. So for episode 1, we have 3 steps, 0, 1, and 2. For episode 2, we have 4 steps, 0, 1, 2, 3. Okay, I think this first part, I thought instead of just going into the widget ops and all that stuff without an example, I thought we could build this to make it as a tutorial and build this together. So so by the end of this, I think I have 30 more minutes. Yeah, maybe in 20 minutes we'll be done, and we should have built something like this. And then if I didn't have enough time to finish it, these are the commits. So I basically I will share the slides, and you'll be able to, for every step, you'll be able to go through, you'll be able to find this commit and find the code for it. But it's basically, the first commit is just an initial setup where I just set up the renderers and the CLI arguments and all that stuff. And then each one of these later commits are one for each widget. So there's one for the episode, one for the step, and one for this visualizer, and one for that. And you'll see that the diffs will show you that I don't modify any of the code of the previous commit. So if I want to add the step, I don't modify the episode at all. If I want to add this, I don't modify any of the others. So I wanted to split them like that so that you can see that there's no dependency going on. Cool. So let's start with the initial setup. So renderers. So this here, what we want to set up is, I don't have any widgets. I just have 3 renderers. There's the main renderer over here, and then we also have 2 more sub renderers, or they're also renderers. They're just so in total we have 3 renderers, and you create a new renderer every time you want to have a different camera, basically. So if I want to have a different camera for this sub renderer, I just basically have to create it as a renderer. Otherwise, I won't have a camera for it, and I can't move in this renderer independently from the others. So let's go to the setup for it. So the setup here is very simple. In order to register a plot, all you need to do is define this. There's a function, give it any name. I call it main, and I just register that plot with this decorator, the register decorator, and this is the name of the plot. This is what you're going to use in CLI to plot it, and then a description. And this description is going to show when you query all the available plots. It's just going to tell you this plot, and it does this plot, and does this. And then if you have any arguments that go into the main function, you can define them here in a different function, and you have to decorate it with attach args and give it the same name of the plot so that it knows how to match it. And then it basically just adds these arguments, and the names of the arguments have to match, right? So experiment logs there needs to match here, and you get the point. All of the code needs to fit inside of this main function, because this is the only function that's going to run. And You can dump all the code here, but I like to create an interactive plot class and run the interactive plot class. So everything runs in the init of this class. But if you're doing a matplotlib or seaborn function, you can just put this stuff here. Doesn't matter. So this is the interactive plot. This is where I create the renderers, for example. So I have, like I said, I have 3 renderers. I learned this trick from Jose. It's actually very nice to be able to specify the render shapes inside the plotter. I used to do it because this shape here takes different ways of defining the renderers. You could do 2 like /1, it will just give you 3 renderers. It will split it into 3 views and then 2 on the top and 1 at the bottom. Or there are different ways you can specify the shapes, but this is actually very useful. So render areas, you can say, okay, my first render is the whole screen, 0, 0 to 1, 1, and then you can have 2 more renderers like this. The things that I'm defining here, and I usually just define all of them, except for maybe this one, which is the YCB mesh loader. I only use this when I want to load a YCB object from the dataset, not something that's not a Monty model, but rather a YCB object. It's a class that makes it very easy. You just give it the graph object name, and it will just return to you a Vido mesh. Data parser, this takes a path to the log file, the JSON log file. Publisher, this is the pub/sub publisher, and this will be shared with all of the widgets later on. So that's how they communicate together. If they all have access to this event bus, then they can all publish and subscribe to the same topics and all of that. The plotter is a Vido plotter that takes the render areas. The scheduler is the debouncer, the debounce scheduler thing. I will talk about it in a minute or so. And then after you define all of these, you want to show the renderers that you have. So we've defined 3 renderers, so we can go through them and show them. These renderers, they take options. So first of all, you can do when you do @0 or @1, that is basically saying I want the first render on the second render and in the same order that you defined them here. And then you need to show that renderer. And if you want to show axes like these ones, do you see my screen when I go between the PowerPoint and the?
Yeah.
Okay. So if you want to show axes like these, you need to provide that in the show function. And you can actually show, like, you can define the ranges for these, like X range, Y range, and so on. I usually put the Y range in between 1.45 and 1.55, and you probably know why. And so basically, you can define a camera as well, or you can set reset camera to true, which is basically going to reset the camera and it will find the objects and it will just reset the camera to a place where it can see all the objects. I don't like to set it unless I don't have anything in there, and just
Wait, so the reset camera, so is that something in Vito or something you implemented?
That's a Vito thing.
And did I understand that correctly? You said it kind of finds something it can see?
Yeah, so it will reset the camera to the objects in the scene, or something like that. Right now, we don't really have an object. So what it does is it probably just goes to a default position and focal point. So the way that you define those camera parameters is a position and a focal point. Focal point is basically where it's looking at, and the position is where it is. If there's nothing in there, it probably just goes to 0, 0, 0 or 0, 0, 1. I like to, especially the main plotter, I like to know where it is. So I define the camera dictionary, and I set reset cam to false. For
so
these ones.
The first one, is that the kind of white background basically, or what does that
Yeah,
correspond
main
to?
screen.
Yeah. the main plotter, which is just basically 0, 0 to 1, 1, the whole thing.
And is there any kind of notion of that it's being nested with the things that are plotted on top of it, or is there like no relationship of like this the parent-child kind of plots?
I don't think there is a. I think Vito treats all of these renderers equally.
Yeah.
So each one
Okay.
is. Yeah.
So it's just the order in which you add them in that order. They are layered on top of each other, but
Yeah.
there's no dependency on how they can access each other's data or anything like that.
No, there's none. Yeah, this is why. So basically, when you want to add an object to a specific renderer, you would just say self.plotter.add that renderer and then .add. You basically you're finding that sub renderer and you're adding to it.
Yeah. And if you wouldn't add the very first one, what would happen? Would there just be
It will probably go to the first renderer. So usually when you don't do .add, I think it just goes to the 0 basically. So add 0 by default.
Oh no, I mean like if you would not do the whole like you don't do the 0, 0 to 1, 1 plot, you only do the two axis windows. Like do you always need the kind of full screen background first?
Uh, I don't really know what happens. Yeah, I could try it. I don't know what
Oh,
happens.
it's
Usually
fine,
just
just
define a plotter. I think it will just go to it. You might not have access to just adding objects in that background.
I think if
So
you don't define anything, it's the full screen naturally. Like if you don't have any renderers, like you would be using all the defaults, I'm guessing. And then if you don't have in the render areas, if you don't have the first one, but only have the small screens, then you'll have like a main window with only information on those small screen areas. Like it will be kind of awkward. Like
But you wouldn't be able to access the first plotter, so you
that's
can't really
right.
add
Yeah.
objects to
Yeah.
it. Or,
These are just like windows into like data and they don't have any like relationship. It's like three computer screens showing stuff.
right.
And then you're saying like, okay, in computer one, I want to show this, in computer two, I want to show this. Yeah.
Yeah. So okay, so the first one is not treated any different from the other ones.
Nope. No, it just happens to be full screen, but like you don't have to make
Yeah,
it.
okay.
Like it makes it so that you can like it makes a like overlay feeling. Like, there's like you subdivided it up, but it's actually like covering,
Yeah,
the second and third one is actually covering information from the first one. So
okay.
so you,
Yeah.
you want to make sure that like when you're plotting, like it doesn't, overlap. So, like
Okay.
Yeah, one other thing to notice here is that I'm setting interactive. So the interactive call basically, once you say that this show is interactive, it will stop processing any code after that. So basically, any code after any changes to the UI is going to only depend on the events. So if something changes, if you interact with something, but it's you just basically this would be the last when you set it to interactive. This would be the last statement here, where anything after that is not going to be used for anything because the code really stops here. This is why I'm making the first two not interactive and then the last one interactive. Um, any changes to the UI or anything like that that happens after this line is going to be through the events. So a slider changed, that calls a callback, and then something that changes. But the interactive call, when you set this, make sure this is the last statement. Okay, so that's basically how you get this setup here. You have one plotter, and then you have two on top of that. So let's start with creating the first widget, which is a slider, the episode slider. I'm showing down here, this is a video showing the topics. I'm just, for the sake of logging, I'm just showing the topics that get published when I change the slider. This is not what we eventually want, but this is just a demo so that I could show the benefits of debouncing and deduplicating. But that's what ends up happening when you just define this widget. So if we want to do this, let's go to the commit for it. from a very high level, you'll see that I have a class that I added, episode slider widget ops. You can name it whatever you want, but it needs to have some functions. And then I modified the interactive plot so that I could add this widget. So the way I do that is the only thing I added here is this piece of code that basically I have a function that says create widgets, and I added the widget here in this specific pattern. We'll talk about it in a second. But I also go through the widgets and I call the add function on that widget class. And if I want to set a state for that widget, like let's say I want to set the episode slider to 0 at the beginning of the code, I could do that here as well. You can do whatever you want. This is just my my way of doing it. So in the create widgets, every widget that we're going to add is just going to be a block like this. There's a widget class. Let me just zoom in. There's a widget class. These are types. We can just ignore them for now. Saying that the widget is a slider and that the state of this widget should be an int. But we can ignore that for now. It's just for type matching. So the widget class takes five things. It takes a widget ops. That's the most important part of the widget, really. That is what customizes the widget. It just basically it says this is a slider, and this is how we add it, this is how we remove it, this is how we extract the state or set its state, and also these are the topics and everything. Like when you define the widget ops, that's the only thing that really makes this widget that widget. This is like the brains of the widget. And that is the class that we defined at the top. So we'll get to that in a second. But also the widget class takes the event bus, which is the publisher and subscriber. It also takes the scheduler for the debouncing and the only debouncing, and then some other variables. I'll talk about these in a second. But let's visit this one because this is the most important part of the widget ops. So as the name suggests, this is a widget operations basically, and it's a class that. So this class doesn't really need to have the way that I've created it. It doesn't really. Trying to find the. So the widget ops they don't really have any requirements in them. So you could actually, the protocol for widget ops is empty. So if you go to widget ops, you'll see that the protocol is empty here. But the reason I'm defining it this way is because I'm adding all the other stuff as capabilities on top of that. Because some widgets don't require you to, they don't need to publish. Other widgets they need to publish, but they don't need to listen to topics. Some widgets you don't need to set state and extract state because they don't really have a state. So all of these are capabilities that if they exist, so what happens is that when we're type matching, it will look for if this function is available with this signature, and if it does, then this widget ops is also an instance of supports add, and if that is the case, then it will do different stuff. So if you have add, then it will end up calling the add function and doing some stuff. If you have if you have state to messages function, it will basically publish the messages that you put in state to messages. Otherwise, it really doesn't publish anything. Let me go back here and give you an example.
And I guess, yeah, at a high level, that this is useful for kind of type checking.
It is type checking, but I'm using it as a way of so I'm using type checking to also dictate the behavior of the widget, because if it doesn't have, so here's how I'm doing it. if it type checks against, like for example, if it finds this function in there, I can use in the widget class, I can say something like if it's not an instance of has updaters. So if it type checks against has updaters and successfully finds that function, then it will do stuff. If it can't find that function, it will just basically return an empty set. So you can
Yeah.
actually use those in the widget.
Yeah.
Yeah.
Thanks.
Sure. Okay, so I think we should just take some time to go through the first one, and then the next one is just going to be we'll talk about the modifications, the changes basically of what the step is, how the step is different from the episode and all the other ones. So I create a function here, create locators. You don't need that. You can create it in it any way you like it. So that this is basically where I define the locators. In this one, I only have only a single locator that just has one path, one step, which is episode, because I'm going to use that to query how many episodes we have so that I can define the episode, the range of the slider. So this is a locator, and it just goes into self dot underscore locators, and it just stays there so that I could use it throughout the code. I have add, and I have extract state, and I have set state, and state to messages. These are the main functions that I need. Add is basically, this is where we add the widget to the plotter, right? It's if add exists, it's going to call that function. And that only happens at the beginning, right? When we do this. So we call add, it's going to look for this function. If it exists, it's going to call it. And what ends up happening here is that, and of course, every widget is different, but the way that I wanted to do this is that I'm going to use the locator. I'm going to get that locator for the episode, and I'm going to query basically how many episodes that we have. And I can use that to modify the X max for the range of the slider. And then I could use this Vido function that adds a slider to this plotter. I'm using plotter 0 because this is where I want my episode. Add slider requires a callback function because that's basically when the slider changes, it's going to call this callback. So my widget class creates a callback for it, and always you're going to have in the add signature, it's just going to give you a callback function, so you can directly pass it here. What happens is that when the slider changes, it's going to call this callback, and that basically the widget class now knows that the slider value has changed, and it will do stuff and publish stuff if it needs to or whatever. So it just needs to go through this through my callback function that I'm defining in the widget class. So yeah, if you're just defining a slider, you could just pass this callback to the add slider callback function, and it will just work fine. I have to do it this way because I need to debounce those messages. And, I will talk about that in a second, debouncing. But yeah, so this is how you add, and then you render. And if you're changing anything to the visualization, you just need to render at the end of changing that. So that is add. There's extract. I have helper functions for the ones that we use a lot, like slider state, or so setting slider state or extracting slider state. I have helper functions for those, so you could just use those. That basically just takes the widget and it knows how to use if it's a slider, it knows how to extract the state from there. And if it's and then it also, for the set slider state, it takes a widget and the value, and it knows how to set the slider state. It's just a bunch of checks and stuff like that. And then the state to messages. There's really nothing here. So if you're going to rely on the state, then you need to tell it how to extract the state, right? So if what you're going to publish relies on this state that you're getting from the widget class, then you need to tell it basically how to extract this state. So you need to have an extract state function as well, because that basically just what happens here is that when it's ready to publish, it will look it will extract the state using the extract state, and then it will send you the state that it has extracted. So you could just use that, or you could just have you could define this value however you want, really. This is the way I'm doing it within the widget class.
When should you pass something in that state variable versus just doing self dot whatever on the class? Because I think in some of the other example code you did self dot episode or something.
Yeah. So if this widget has a state, sometimes widgets can have multiple states. So I tried not to. So for simple widgets like an episode, it's easy to just use this functionality. It would extract state and define exactly how to extract the state from the slider, and then it will just provide that state here. Sometimes the state is a bit more complicated than that. Let's say you're passing you're selecting a hypothesis and you're sending a whole pandas data frame or a series or something like that. Then you can just ignore this state and you can just pass in a state that is defined within the widget ops. So you can define your own states within widget ops, and you can say, when I'm publishing, I just want to say if that selection has been made, just return self.this state. Whatever you put here in the value is the message that's going to be sent, basically. So it could be the states if you're relying on the widget to extract that for you, or it could be something else. You could put in true or false, whatever you want.
Okay.
So that's really it for the episode. We've added it here, and we've defined the widget ops. All of the other ones are going to be just this same pattern. I'm going to add another widget here, and I'm going to define its widget ops, and that's it. So if you want to extract some functionality, you can just take this whole widget ops, move it to another plot, and that's it. That's how I created this tutorial, basically. Okay, so let's go. So yeah, so let me also explain the debouncing a little bit. So, and deduplicating. So first deduplicating. So the difference between this and what we had before is that here in the widget class, I'm setting deduplicate to true, which means if the state is the same, it just doesn't send the message again, right? So because that state can before what was happening is even though we're moving it like this, the state is the same and it's still just publishing messages. And that if you have an expensive callback function that is triggered by this event, then it's going to become non-responsive. So if you don't want that to happen, you can set deduplicate to true, and it will just only send a message after the state has changed. But that's
and just, I guess in this case, because it's not that clear in the video, the 0 to 1 only changes at the midpoint.
Yeah.
So like for the first half of the bar, it's all 0.
Yep.
But as you showed in the example, it was just because the bar was moving, it was publishing loads.
Yep. Yeah, exactly. But if we keep moving between 0 and 1, it will still publish a lot. And that's another thing. So if let's say you have 50 episodes and every episode is just changing the mesh, and changing the mesh is actually an expensive operation. So as you go between them, it will very quickly become very non-responsive because you're changing from 0 to 1 to 3 to 4. And that's not a problem of deduplication. The actual state is changing. So that's why I need debouncing. What debouncing is it basically postpones the firing of the topic until the firing of the message until you become inactive in like so basically here, let me show you. So this is with debounce seconds greater than 0. what happens is that I'm moving between 0 and 1, and it just doesn't publish until I stop moving for 0.3 seconds. Right. So it's like a throttle, but different in the way that the logic works. So yeah, I use this a lot because I don't want to send a message as I'm moving from episode 0 to episode 5. I wanted to wait until I'm stopped.
Yeah, I remember
Okay.
you saying it was like lagging, particularly with like point clouds and meshes and stuff. If
Yeah.
like every time this slider moved,
It was lagging, and it also would, depending on how expensive the call is, it will be the way that this happens is that it will just do it recursively. So if you just move quickly, very, very quickly, it will basically just fail. It will reach recursion maximum depth, and it will just fail. So yeah, so this is helpful. Okay, let's quick. I don't know how much time I have. I think I have like 2 minutes, but let's. I'm
yeah,
gonna
I
go.
mean, no worries if you go a bit over.
Okay, so maybe it's just 10 more minutes or something.
Yeah.
So let's add a new episode, a new slider here, the step. Now these are going to go quicker because we already know the pattern. So let's go to the commit. And the only thing I added here was this widget ops for the step slider, and I added a new widget class for it. And I'm just giving it this new class for the widget ops, and I'm saying I wanted to debounce with 0.3 seconds. I wanted to deduplicate true. That's the only change here. Now here we have a difference. The difference is that we have widget updaters, and this is something that we didn't have before. So the widget updaters for this step is very simple here. It's just saying I'm going to listen to the episode number, and if that changes, I'm going to call this callback function. And the callback, I'm defining that here as one of the, here, it's update slider range. I'm just passing this callback. So updaters work with also a very specific signature. The way that I thought about it is that updaters, when you call an updater callback, you want to modify the widget. So what you give it is the widget itself, so you can modify it, and you give it a list of the messages that you received. So all of the ones that you were listening to here, all the required ones are going to be sent. So this one, right now we only have one, so this list is just only going to contain that same message, basically. So all of the updated messages, you're gonna get them here, and you're gonna get the widget. You define what happens to the widget based on these messages, basically. So we got the episode number in here, so I'm going to decode these messages. I'm just decoding it from the topic message into a dictionary. I just found it easier sometimes to do that. And I'm going to change the widget range from, it's now going to start at 0 and it's going to end at this value. Now this value, I'm using the data parser.query to get basically how many steps we have, right? We went over queries before, but this is my data parser. And the data parser for step just doesn't have episode number because I don't know what the episode is. And what I'm looking to get is the step, right? So I'm going to query this by giving it the episode number that I receive. And these are constants, so I'm providing those. And it will just give me how many steps that I have here. And once I do that, I'm just setting the range, the widget range to that. And I am setting the state of the widget back to 0 because we don't, yeah, once the episode changes, I want to send it back to 0. And I just render, that's all. I return back the widget. I always return back the widget because this is the modified widget. So it's basically I get a widget, I modify it, I send it back. That's the pattern for all of these callbacks. And I also send back a true or false. When I send back true, it publishes the new state. When I send back false, it just doesn't publish. This is the whole pattern.
And maybe I missed this, but why are plotter.add calling to 0? I thought 0 was the kind of blank screen.
Yes, because this slider is on the first renderer
Oh,
of the
okay.
main.
That's on the background. Okay.
For the next two objects, we're going to call plotter.add 1 and 2. The
Okay.
slider is on the background.
Just out of interest, how clever is Vito about like positioning those? Does that take a lot of tweaking in practice to?
So no, so when you, I think it is actually very smart in terms of, so if you are, so these numbers like 0.1 to, so here, when I say 0.1, so this is the position of the slider, and I say 0.1 on the X to 0.9, I think it scales with the size of the renderer. So it's nice. You can take this whole thing and you just move it in a sub renderer and it will just scale and work nicely. So it is smart in that respect, but
Yeah. Okay, cool. Thanks.
sure. Yeah, so that's it. This is it for the slider. So if this works, we should have something like this. Basically, when you change the episode number, so for example, episode 0, we have 27 steps. And if you change the episode number, it will go back to 0. And when you check, it will have 30 steps. So it's already updating the step because it's listening to that topic. Okay, let's go to the
Like just about the like smart thing, like the positions of the sliders can be smart, but like little things like, for example, the numbers, you can make the number show up or hide it. I found that out, but then you can't really like control where the number is placed. Like you can't put it on the bottom or you can't change the spacing. So like I had a situation where there was a number, but then I had a button on top of it. So it was kind of hiding the number, like occluding the number a little bit. So I had to manually like, increase the like button a little bit higher, yada yada. I guess typical plotting problems, but yeah, like you don't have full control over like every aspect, just FYI.
yeah,
Yeah, good.
so if you want to have more control, so this is, like I said, this is I may have not mentioned it, but this is a wrapper over VTK. VTK is created by Kitware, and it's very good. It's so much of a learning rate that like it's not very easy to learn VTK, but I suggest if you just want to customize this more, then VTK is the way to go. Okay. So let's create this here. So this is the plotter 1, basically index 1. Then what we want to have is as we change the episode, it changes the object, the mesh, the primary target, and as we move this step slider, it changes the sensor position. And we're going to query that stuff from the data parser and display it. Okay. Again, it's the same exact pattern. We just added a class for the ground truth mesh widget ops, and we added that down there for the widgets. And so what we're listening to here is we have updaters, and what we're listening to is we have two updaters. One that will update the mesh. I may have mentioned this before already. So one will update the mesh and it listens to the episode number, and this is just updating the primary target. And another one is going to listen to both of these, the step number and the episode number, and it will update the sensor. Now this is the moving sensor. The locators are a bit more involved, but again, this just shows how easy it is to get data. So I've created 4 locators. The target, which is here, this only is missing the episode. The steps mask, I need that to process the sensor locations because these are, so when I get the sensor location, I'm getting it from the SM steps. So I need to also know which ones have been processed. So I get that from the steps mask. The missing value here is also episode. Here I have the missing value is episode and the SM step. So when I call this, all I need to give it is episode and SM step. And then I also have the patch location. I'm getting that from this path here. Yeah, so really, when it's time to update the mesh, this only listens to the episode number. So again, I'm just removing the old mesh and I'm adding the new mesh. So I'm calling the YCB loader, which I talked about in the beginning of this. It basically, I just give it the target ID, a string basically of the mesh that I'm trying to load, and it will create the widget for me. I rotate it based on the information I extracted from the data parser, and then I shift it and then add it to the plotter. So now here we're using plotter.add.1, and then I render that plot. That's it. I don't want to publish anything. I just return widget again and false. So that's how you update the mesh. To update the sensor, it's a similar thing, except that now I'm updating. So here in the init function, I created these variables, gaze line and sensor circle, which are the red sphere and the gaze line. They're empty right now, but they're going to take line object, line widget or line object and a circle object. I think this is wrong. I need to change that to sphere. But yeah, so updating the sensors is as simple as that. Getting the messages, and here I'm just going to get the sensor position and the patch position, and I'm just going to update the sensor circle and the gaze line and make it look at the correct place.
And what was the return bool again? The second return.
Basically, do we want to publish the state after we update the sensor?
Okay. Yeah. Thanks.
Yeah. So that's it. That's really all that it takes to create this nice visualization. And let's do the last one quickly. It's again the same kind of pattern. Just added a class for it. And the updaters here are going to be listening now to the episode number and the step number. If any of those change, we will update the MLH. And it calls the update mesh. I'm defining a sensor circle here. So this is the object for the sphere, again, not circle. And I'm adding a little bit of text to the plotter at 2. I'm just adding that at the top. Just says MLH. The locators are simpler here because I only need to extract the MLH. So I'm just defining that this MLH depends on the episode and the step. Both these in the middle are already fixed, the current MLH and LM0. But if you have like a slider here, you can also change that LM0 to something else. An update mesh is this is the only function I added. Basically, I remove the widgets that already exist, the existing widget for the object, and then the sensor circle, I also remove it. And then I extract the MLH here by giving it the episode and the step. And these are the MLH stuff. It's a dictionary when I extract it. So I'm getting the graph ID, rotation, and location. I add the object, rotate it, shift it into position, and add the sphere for the sensor circle. And again, plot. So it's as simple as that. I already copied all of this code from existing other plots. So I know it works by just copying it over. As long as you can connect them through these topics, episode number and step number, if you use that everywhere, then you can just reuse the functionality. Or if I'm copying a widget from like a visualization from Hoj, and she's using episode num, for example, I could just rename that if I wanted to. Like, it's not a big change. But yeah, as long as you use those, it should be reusable. That's it. This is if you do that, you'll have this visualization. So it's a bit of code to add all of these classes, but I think it just makes it easy to just extract functionality, move it away. And it also makes the code very readable. You could go through the code and see what's going on. Yep, I think this is all.